Okay, my friends, let me just start off by saying we have found these particles, and this just came out today, saying we finally know where to look for the universe's most sought after particle. Well, what is this sought after particle? They're saying neutron stars with a penchant for extreme spinning could be churning out one of the most sought after particles in the universe. And what is that? These elementary particles are called axions, and to date they are purely hypothetical. If we did manage to find them, though, we could solve some of the biggest problems in the cosmos, including the identity of at least one kind of dark matter. Well, let me tell you something. We did find them. They're called these axions, and I will prove it to you right now. Okay, so I am going to drag you through the soup with me. We're going to go in and look at what they're talking about, this most sought after particle. Could this be it? Wow, could it be it? We've been misreading a major law of physics for 300 years. Are you kidding me? Well, let's find out. All right, this goes back to 2013. This is Fermilab. And this is a fixed particle. They call it extended fixed. This is the point-like particle that chat talks about. But this is the extended particle with a glowy edge around it. And down here it says, in summary, the extended particle, the one with the glowy edge, has a fixed size with a fuzzy edge. It's fixed, it never changes. And a point-like particle is just an abstract. It has no size at all to it. And it has no weight. I agree with that. This is all the weight and no real energy. This has all the energy and no weight. It's just the opposite. So call it matter, antimatter, call it anything you want. But this is the one that's glued to these. The two of them back to back make what they call a gluon, and that's all that exists are these two particles. And when you put those little tiny bar magnets, and all they are is bar magnets, when you put them all in a big mass, they become stable at certain periods, and that's what they call a periodic table of elements. Only certain balls become stable, and then they're stable. And if you take some of the little pieces off, they become unstable. That's what radioactivity is. Okay, these are the particles. That's the fixed one, and that's the point-like particle. We found exactly what they claim. And here's the ones with the glowy edge, just like that, the red one. And here's the point-like particles, which get bigger and smaller. See how little that one is, how big that one is? It's because it's going through the air this way. And this one is being concussed, and this one's being protected by the black particle. This is what it looks like. This is the colorized version. Now, not only did we see them as light, we put them through an accelerator, which was a Venturi. It's a fully understood principle, a Venturi. And it made the light accelerate. It's just, that's how it works. And it sucked the actual particle right out of the wave. It concussed here. And as you saw before, they were black and white tied together. They were just, and I mean tight. But at the Venturi, the fixed one can't get through. The fixed one can't get through, so it stays on this side. Boom, 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 because it's pulsed. Slap, 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 slap. The white is shooting through. And then it recombines with black over here. Now, they talk about entangled photons. And this is a photon. Light is photons. It's a photon, no question about that. That is a photon of light, zero question. That came out of a red pulsed laser, and we have them in the green too. And the green does exactly the same thing. That is a photon in the green. Same thing. And as they change speeds, they change flavors, they call it. And when they hit a certain point, they actually manifest as a full photon. And that's just at that point of impact, basically. Now, we have concussion backwards, so they manifest right in the middle of the air. Let me show you what I mean by that. Here's red. Here's red. And it's going pulse, pulse, pulse. And that's just out of these tiny little lasers. And they don't really look like photons here. You see, but you can see the black and white. There's no question we got black and white. No question whatsoever. And it's laying down like an Oreo cookie. Well, what happens here? All of a sudden it twists up this way. You see them going this way? And then the one exactly in line with the Venturi, the only one that's exactly in line, starts to show as a photon. You say, why is that? Why don't these show as photons? Why don't these show as photons? Why do we see a photon here? Can you explain that to me? I can explain it to you, which I will right now. It's coming in, and it's not fully puffed up. Now, you really have to pay attention to the details here. As it increases energy, for some reason, and I can't tell you why, it flips on its side this way. So from flat this way, it flips up. These are different flavors, and they're all flipping up, basically. This one, though, goes one step further. This one turns right into its photon, which is the black and white back-to-back bar magnets, basically. Now, if you see this one, if you measured this distance up from here versus that one, there's going to be a difference. This is a little squattier. I can't really tell you exactly the difference, but just look at it yourself. Take your time. You can see this is not as brilliant as this one, first of all, and secondly, it's a little flatter. That's what I see. I don't know what you see. Now, as that one hits the Venturi, it just explodes. Now, the reason this one is puffier way out here, and none of the other ones, you don't see any photons up here. They're all here. They are here. They're just not fully photons. A photon appears to me to only make a true photon at the point of impact. And this is not a point of impact. Well, why would it make it out there? Well, it thinks it is. And the reason is it's coming here at a bazillion miles an hour, and this is banging back this way at who knows how fast. And between the two of them hitting together in midair, it thinks it just hit a wall. So it's ready to bounce back as a fully fledged photon. The rest of them you never see. You never see that in the CERN experiments. You just can't see. Well, you can see them, but they don't know what they see. Here's what they see. These are the CERN ones. Hold on, right here. Here's what they're doing. They're taking big balls of dipoles. They don't realize it. These are two big balls of dipoles. And a dipole, every one of them is an electron, which has a mass, and there's 1800, it's 1836, 39, 1823. I've floated a bunch of numbers back and forth, but according to Millikan's oil drop experiment, he's claiming there's 1836. I can't disagree with his experiment, so I don't know. But the weight of each electron, and there is a weight to it, is 0.00058548 or something like that, atomic mass units. And 1836 of them make one. All right, so if you divide 1 by 1836, that's what each one of them weighs. That's what he claims. Could be. But they're in a ball like this. It's not not a proton like this. It has just a couple of zoo of particles. Every one of these particles comes from one of these, from just one. And there's a black and a white in there. All right? And they can see all these things, but then they see chunks like this, huge chunks. And they really can't do anything to really understand the particle nature, because it's just a swamp of debris. It's just debris. They call it a particle zoo, yes. They can't understand any of that. We understand it because we see it actually manifesting itself. Here's the, I got something here to show the whole batch of them at once. All right, here's what happens. Just follow me through on this. Pulse red laser, boop, 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 boop. And you wouldn't even see this if it wasn't starting to accelerate. The only reason you even see these waves is because it's beginning now to accelerate. It's right about here. All right? So we're seeing this wave. You don't see them up here. You don't see them down here. You don't see them anywhere else. The only way you see it is just because it's straight in line with the Venturi. These are the things that you got to pay attention to. And the only reason you see these waves here, they're the same as these. They're all over the place. And you can see them right here because of the explosion. The pushback atom is what's causing them to become photons. Just like I showed you, they push back on these as they're just about to hit the Venturi is why these show up as photons. These way back out here show up as photons because they're being pushed back so hard, they're coming forward and they're not hitting anything hard enough to be visible. But when this pushback comes this way, they think they just hit a wall. That's why you see them here. Now, what comes out of the Venturi? Higgs fields. These are Higgs fields. Just go get your physicists and ask them, that's what's happening. And why are they Higgs fields? Well, the white particle is completely separated from the black particle. All right, so we got the black and the white, and the black is completely separated from the white now. 100% separated at the Venturi. That's fission. It comes through the Venturi, and the Higgs fields is when they come back together as fusion. There has to be black particles just waiting here to refuse. Fission, fusion. The Higgs fields are the product of fusion. Higgs fields are from fusion. Now, I got some other really crazy one. This one here is, I understand this, and I can explain this to any physicist that would like to discuss this. These Higgs fields, there was a reverse Higgs field. Now, how could you make a reverse Higgs field? Well, I can show that, and I have the stuff to prove it. Now, everything I'm saying I can prove. I don't have anything here that I cannot prove. And I can also prove that we're doing what they want to do, and they are doing it only with Cherenkov radiation, which is just basically just heats up water. Muon and neutrinos are attached to electron neutrinos, the black and the white. Well, the muon neutrino, the black one just goes off on its own. And the white one is so powerful that when it hits, they're extremely high-powered electron neutrinos. When they hit the water, the heavy water, they create all these showers. So that's where you get the electron showers. We don't have to do that. We just did that right in midair. We don't have to do Cherenkov radiation in water. Okay, this just so you understand fully, this is dipole electron flood theory. I've had this for over 50 years. There's no way that they could account for they can't account for anything basically. No gravity, no nothing, no dark matter. So, and they couldn't because they wanted to stay with Einstein and all the rest of them with their rules and laws and constrictions and restraints, and it's just not right. They never knew that there was a dark particle attached to the glowy particle, which was always considered the electron. A dipole electron changes everything there is, and I mean literally everything. If you look up and ask ChatGPT, if an electron is a dipole, what does it change? It says changes everything there is, 100%. And I mean not just in physics, but everything, everything that we've ever thought about. And these are the only two particles that exist. Those are the dipoles. The black and the white, that's it. One of those weighs a very small amount. And if you took 1,835 or 40, somewhere around there, add it together, it makes one proton like this. And the black just congeals in the center and the white goes around it. That's why we've never seen the black. It's in everything there is. Everything there's dark matter in every... Light has dark matter in it. Light is half dark matter. And here's what light is. That's what light is right there. It's a photon. It's half dark matter and half glowy matter. An electron is what they call a gluon, all right, which is the black and the white. That's it. That's the smallest particle, and that's heat, literally heat. Light is, and heat and light, so forth, yes. Light is the photons back to back. Now, when you get into electricity, it's different. Electricity is only the white. It has no weight whatsoever. Electricity has no weight whatsoever. If you take electricity and fill up a battery, all you're doing is putting the white in it, and the battery doesn't gain any weight whatsoever, but a ton of power. You drive all day long in your car and never change weight. When you refill it up with electricity, it still doesn't change weight. Gasoline, you fill it up, it's just, you got 10 gallons is 60 pounds, 6-0. This electricity, 0. And these are the only two parts that exist, and it changes everything. The space, redshift is nonsense. They think his redshift is because it's pulling out. And even your chat says, yeah, that changes the Great Big Bang and everything. If I'm right, literally everything changes. And I mean everything. Not just a little here and a little there. Everything. Okay, my friends, I have basically shown without a doubt that dipoles, electrons are dipoles. And this is ChatGPT. It says if protons were made of dipole electrons, it would indeed require a massive reevaluation of fundamental physics, but not necessarily a complete overhaul of every aspect of physics. And then it goes on to say virtually everything would have to change. And at the bottom, it sums it up by saying this. It's cosmology, Big Bang, all this stuff, everything changes. So they come down, it would indeed revolutionize our understanding and require new theories to describe the forces. This is about dipole electrons. Let me just start again. It says, let's just start right here, implications for cosmology. The existence of quarks and their interactions plays a major role in early universe cosmology. It's just not true. A different structure for protons would have far-reaching implications for those theories on the Big Bang because they're just not right. The formation of elements and evolution of the universe, all of that is wrong. In summary, if protons were somehow found to be made of dipole electrons, it would indeed revolutionize our understanding and require new theories to describe forces, particle structure, interactions across all scales. Some aspects of physics might remain consistent, such as the principle of conservation of energy and charge. That I do sort of agree with. But the foundational framework would undergo a substantial transformation. And I am showing you what I'm telling you is true. And nobody can stand up in front of it and say it's not true, because I show you the evidence, not just guesses. All right, so don't forget, they're looking for these axions. And an axion is a dipole, and we found them. Okay, this is hard to believe, but it is a fact. These smallest elementary particles are called axions. To date, they are purely hypothetical. If we did manage to find them, though, we could solve some of the biggest problems in the cosmos, including the identity of dark matter. Now, we did find those. Well, what is an axion? It's a dipole. My whole theory is dipole electron flood theory. So don't forget. An axion is what they're looking for. I put in is an axion polar. This is ChatGPT. So yes, an axion is considered a hypothetical particle, could potentially have a polar nature in the sense of influencing polarization effects. Polar just means it's got a positive and a negative. This interaction, often called the axion-photon coupling, all right, which it is, the two axions together, would indeed make axions relevant to polarization in certain fields, although axions themselves are not directly polar particles in a typical sense. Yes, they are. They're 100% polar. 100%. I think I showed you this, but if electrons are dipoles, does it change the Big Bang theory? And this is ChatGPT again. If electrons were found to be dipoles, yes, it would change everything. It would have profound implications, fundamental physics, cosmology, impacting the Big Bang theory and our understanding of the universe's origins. Absolutely, 100%. And it does. And all the other things I found that they are discovering in space, like comet asteroid Bennu, which they just returned with a sample, I know exactly what it is. I want to be involved in our scientific discussions, and I am prevented because my discussions fall outside of the realm of what's considered scientific. They view me as a pseudoscientist, an amateur, somebody that just hasn't learned enough from other people. I don't need to learn from other people. They need to learn from me. And like I said, it ain't bragging if it's true. They need to learn from dipole electron flood theory, because we not only finally know what to look for, we found it. So they were going to know, we can look out here. They don't even realize that light slows down. It's absolutely incredible what is not known. It's beyond the belief of anybody that's outside of science to understand. They can't, first of all, they can't talk about it. Otherwise, they get thrown off the bus. Exactly what happened to me. And secondly, they just don't understand it because they have to repeat what they're being told, and they get so well indoctrinated that they actually believe it. Right? These elementary particles are called axions. That's the positive and negative. I showed you chat. You just asked what chat says about them. They're dipoles. Purely hypothetical. No, they're not. If we did manage to find them, we could solve the biggest problems in the cosmos, including identity of at least one kind of dark matter. And we now know that the things that are in space are not just rocks and debris. I fully understand them, and I have a dozen, well, I have at least a half a dozen perfect examples of asteroids or meteorites here. And I can show you exactly what's in them. Because I go into the particles. I go deep into them. And I understand the chemistry of them. So I want to be involved in these scientific discussions. And I'm outside the realm because I talk about things in space being biological. And I can prove they are. And Bennu is back here on Earth, a sample from Bennu. I know exactly what it is. I've said it over and over and over and over. Go back to some of my other videos. Bennu is a literal heart. Heart. At one time. And now it is the body part of a heart in space. There was battles in the heavens. Get over it. All of that ancient stuff was true. Just a fact. Just a fact. All right, I showed you what a boondoggle Fermilab is and all the rest of them. This is just as bad. This is Comet Bennu, or Asteroid Bennu. They went out and picked up a sample. Now, Arizona, University of Arizona, they're not doing their job. I've been trying to get a hold of them. I know exactly what this thing is, and it is literally a heart. And they brought it back, and it has the phosphate layers, which are the membranes, phospholipid membranes, and then in between it has the sarcomeres. And I can't get through to anybody out there. And this just happens, it's right across the board. And I don't know why they don't want to have this evidence known. I have my suspicions. But I'll show you what they're looking for. Bennu holds the solar system's original ingredients. Yeah, it's biology. Now, I sent it to a slew of people, but he's over here. He's the principal investigator, Dante Loretta. I sent him all the information I said, and I explained exactly, and I put some pictures and all the, the evidence in with it. Haven't heard anything back. And he's at Arizona University there, whatever it is. And they got the money to do all this work. And this has already been back here for a year. And I knew what it was even before they came back with it. It's there's no question what it is. Okay, here's another $1.16 billion boondoggle. This is Bennu. They went up there and took a sample from this asteroid, brought it back to Earth, and its heart. It's a heart, and they brought back heart muscle and membranes. This is heart muscle. These little blocks are muscle, and they're between these phosphate layers, which are bilipid phospholayers, and phosphorus. And that's a heart muscle. And they brought this back, and it's here on Earth, and it's been here for a year, and they're talking about maybe another couple of years they'll be able to figure out something about it. You see that? That's the sarcomeres, and so are those. Those are muscle sarcomeres from a heart. Exact same thing. They have the layers, phospho layers above and below, and in between is sandwiched the muscle sarcomeres. There's no difference whatsoever. There it is right there. You come up and look at it, and there's Bennu. That's a heart. No question. Zero question about this. Zero questione. All right? Way back in the beginning, I think I show it here. Somewhere. I thought I did. Hold on. All right, I thought I showed this before, but maybe not. This is the heart, and that is the heart of Bennu, and that is a psyche. That's another heart. This is what the heart is, and the plumbing comes right off of here, and you look down into the valves. These are the valves. I've shown this in so much detail, it can't be denied. And the samples that they brought back are muscle sarcomeres. I just showed you. Now this is another thing like Fermilab. They can't see what's in front of their eyes. That's not a crater. That's a tube. That's a tube. These colors are the colors of blood. The sarcomere is a sarcomere. That's a tendon. This is all heart muscle. And now come up here and, pay attention to my videos. This one here is asteroid Bennu autopsy appears conclusive. Please leave a comment. Thank you for your dedication to this work. Da, 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 da. Sir, you hit the target. Thank you. I believe everything. Amazing stuff. I am presenting the facts. I present evidence. I don't present just nothing. And this is here on Earth from that exact asteroid. This cannot be denied, and we have spent $1.16 billion already. And that doesn't account for a lot of the costs. And then they're talking about not being able to know much about this for who knows how long. I predicted exactly what it was before it came back to Earth. And this is not right. And the University of Arizona is being funded, apparently, by whoever, NASA. Well, it's coming out of our own pockets. I guarantee you of that. You and I are paying for this. I call it a boondoggle. They're not doing their job. If they did, they would correspond back. And I have gotten no correspondence from anybody involved in this. And from nobody any involved in anywhere in physics or astrophysics or any of that stuff. Because it just, it's just over the top. They can't accept it. It's just too much. You're like, oh, help, don't talk to me about this stuff. Run for your life. That's what they're doing. So anyway, it's time to stop this nonsense. Let's pay attention to reality. There's no higher degree of intelligence than opening your mind and looking, not just dismissing. There's science and then there's deniance. We're in a phase of deniance. When you come up with something like I bring out with the evidence, and everything I bring is material evidence. I'm a material scientist. I do material research. I show the evidence that supports the statements I make. I don't just make statements without evidence. None. Zero ever. And the evidence sits right in the University of Arizona. And how they can't see this, I have no idea. All right, I love you all. Let's get out of this system of deniance and get to really science, where we investigate, we talk, we have forums, we have chats about this with people that are the ones that are supposed to be the teachers. Right now, they're not teaching. They're saying, don't listen to anything that we don't tell you, or we'll fail you. So you're stuck. What are you going to do? All right, I love you. Bye.